Day 6, pendulums. My teacher gave to me 6 pairs of goggles. Pendulums. They're really kind of simple, but they have played an important part in the development of motion and particularly clocks and time. A pendulum has basically 3 parts: a bob, a cord, and a pivot point. Now what you see right here is something we call harmonic oscillation, which is a fancy word of saying it repeats the pattern over and over again, and it's swinging back and forth. Galileo, early on in the 1600s, the story goes, noticed that a chandelier was swinging in his church, and he started studying motion. Before him, Aristotle had studied it, and after him, Newton and even Einstein have studied motion. But what he learned from the pendulum was pretty amazing. See, we told time was by the day and the night, that cycle. But clocks could not do anything very accurate. There was no accurate clock. But here's what Galileo discovered, that when you displace a pendulum, by displacement means how far off the center. So if I just put it like this, that's its period. And if I even displace it more, like way up here, the period is the same. Even if I double the mass, the period's the same. What he discovered is the way to change the rate of a pendulum has to do with the length of the cord. So if I have a short cord, we have a quick period. If I have a long cord, now he and some of his colleagues decided, I wonder what is the correct length for 1 second. So they set up a famous experiment. During the night, they looked at a star, and as the Earth rotated, they started swinging a pendulum, giving it special little pushes to keep it going all through the night, all through the next day, until that star, the Earth rotated, and was right above the point on that roof. And they counted those, and from that, they were able to determine how to make a Galileo clock a second, and that's how all of our clocks and watches today have to do with harmonic oscillation. But just, you can try this at home. Here is a large pendulum, and I have the period. And if I move it up a little bit farther, like say up here, and if you just watch the red marker, let's see what happens. And that is the beauty of a clock with a pendulum. It was the first way to make accurate time, and then scientists could start quantifying their experiments. Now, if you put a bunch of these, check out this pendulum right here. This pendulum has all at the same level, but different lengths. So they should all rotate back and forth at a different rate. Let's see if I can get this right. Here we go. And you start to see some patterns. Maybe you'll see them. I see them. Here we go. 3, 2, 1. I could watch that all day. Slow, long, quick, short. And you start to see these come in and out of sync. I start to see patterns. You should too. Oh, now we're getting back to 3s and 2s. And that is amazing. In fact, there's a whole bunch you can do with pendulums. Let me show you this next one right here. This is pretty amazing. There was a clockmaker who was using a clock, and he noticed that he was homesick one day, and his clock was on the mantle, tick-tock, tick-tock, and he noticed that all 3 of his clocks were moving in the same harmonic oscillation. It's because the energy was going through from clock to clock, and they were getting in sync. So here we have 2 cans on a string, and the string allows the vibration to go through. Watch what happens when I let this one go. Back and forth, back and forth. But what's going to happen if I let one go and not this one? Let's find out. Ready? You can do this at home or in your classroom. Now it's going back and forth, and it's going back and forth. The energy is harmonic oscillations are traveling through, and now it's slowing down, and this one's going back and forth. I wonder if it's going to send that harmonic energy back through again. Let's see what happens. Yep, This one's starting to go. This one's starting to slow down. They're both moving. That's pretty cool. Motion is all around us. If you use your eyes and your ears, there's a lot you can observe. I got one more, but this one takes just a little bit bigger setup. If a small pendulum works, a large pendulum ought to work. So I hooked this 12-pound bowling ball up to a pivot. It's my bob, and it's got a lot of potential energy. And we know potential energy turns into kinetic if I let it go. Hope it doesn't hurt this, this Christmas ornament. Let's see what happens. 3, 2, 1. Oh, that's fine, that's fine, that's fine. And, oh, okay, that could be a problem. For this next thing, here you go. All right, in a closed system, I'd be in big trouble. Potential energy, 3, wait a minute, but I know about friction. Friction is the interaction between two objects. In this case, between this ball and the air. And I'm counting on friction slowing this ball down and not ruining this handsome face. Here we go. I hate this part. 3, 2, 1. Now a brave man would run right now, but okay, I believe in science. Oh, and you notice each time, because of friction between the air, it is slowing down. And a little bit of friction up there in the pivot point. If only we could turn this room into a vacuum, the thing would go all the way, well, I don't know. Hey, pendulums.